Hello there, welcome back to another derivatives video. Today we're going to be finishing off the derivative rules with product rule and quotient rule. Now in my opinion, these rules are quite boring because they're quite formulaic. It's very easy to just follow the formula and get it right. But they're still really important, which is why we're going to be putting in some practice problems, and I'm going to be making sure that these are very easy to understand. So by the end of this video, you'll have a solid understanding of product rule and quotient rule. So let's get into it. Product rule. Product rule is when you have two functions that are multiplied by each other. This could be x squared times e to the x. This could be x times ln x. This could be x plus 1 whole squared times x plus 2. But it's whenever you have two functions with x's that are multiplied by each other. So remember, product rule is always used when there's multiplication involved of two variables. And the product rule is actually really easy to use. You have a product of two functions. So what you do is you take the first function as it is, and then you multiply it by the derivative of the second function, and then you add that to the derivative of the first function multiplied by the second function. And in this case, order doesn't matter. So you could flip these around and that would still be the same. All you have to know is that I take the derivative of one, multiply the other, and then I take the derivative of the other and multiply by the first one. So let's get into a couple examples. The first example is the derivative of x squared e to the x. So we can write this as, so let's take the derivative of x squared first. So we do x squared prime times e to the x plus e to the x prime times x squared. So as we learned product rule the other day, we can find the derivative of x squared pretty easily. We put the 2 in front and we subtract 1, so it's 2x, and then multiply that by e to the x, plus the derivative of e to the x is e to the x, and maybe we can get into that in another video, but these are just simple formulas which we can cover later. And e to the x times x squared. And that's basically it. And then we can open this up. So we can say 2x e to the x plus x squared e to the x. And then if you want to be really fancy with this, right, you can also factor out x e to the x as a common factor. And you can say it's 2 plus x, like that. This is especially useful when you want to try and find the roots. And we'll go to that later and about finding roots of derivatives. But this form, when you simplify it fully, is probably the most useful. Okay, let's move on to the next question. This one's also relatively simple. It's just simple application of product rule. So again, we'll take the derivative of x first. So we do x prime times ln x plus ln x prime times x, right? And then derivative of x is just 1, so we use power rule there, and then multiply that by ln x. And then the derivative of ln x is 1 over x, and this we can cover later. This is also similar to e to the x. You can find a proof for this derivative and multiply that by x. And then we can simplify this, so we get ln x plus x over x. X over x is just 1, so we get ln x plus 1. That right there is our final answer. So not too bad. Okay, let's get into another question. And this time, what we're going to do is we're going to combine power rule questions with product rule. So, okay, so it's going to be slightly longer. So it's important that we stay organized, because one issue with product rule is that it's very easy to make silly mistakes. So we want to make sure we are as organized as possible. And yeah, so let's get into it. Okay, so with this problem, it's a combination of product rule, because we have two things being multiplied by each other, but we also have power rule here. So it's going to be slightly more complicated. So let's take the derivative of this term first. So let's write the whole thing down, x cubed plus x squared plus 5. I have to write a bit small so that I can fit everything. X to the power 4 minus 8x minus 2 plus x cubed plus x squared plus 5 times x to the power 4 minus 8x minus 2 prime. Okay, and then let's use power rule to find the derivative of this first. So we get the derivative of x cubed, so we take the cube, put it down here, so it's 3x squared. So let's put that in. 3x squared plus derivative of x is 2x. And then this 5 is a constant, so we don't need to consider it. It's just 0. That's our derivative. Multiply that by x to the power 4 minus 8x minus 2 plus, and then we keep the first term the same. And then we take the derivative of this term now. So we bring 4 to one side, so it becomes 4x, and then subtract 1 from the power cubed, minus 8x, so we take 1 down. So 8 times x to the power of 0, which is 1. And then 2 is a constant, so we don't need to consider it. That right there is our fully expanded form. Now you can simplify this by multiplying themselves, but I think it's a waste of time right now, since it's just foiling and it takes a while. So now we'll move on to quotient rule. In my opinion, quotient rule is one of my least favorite rules because it's just hard to remember and it's a little bit annoying to use, because in this case order does matter, right? You want to always take the derivative of the numerator first, and you want to multiply that by just the denominator, and then you take the numerator and multiply by the derivative of the denominator, and then you divide that by denominator squared. And this, I think you can prove this using product rule. It's actually quite easy to prove. You can, for example, if you have something like e to the x divided by x, you can simplify that to e to the x times x to the negative 1, and then you can apply product rule. And this is just an extension of the product rule. Other than being annoying to remember and a little bit boring, it's also easy to make mistakes. So it's really important that we organize ourselves with this problem as well. But in general, it's very easy to spot and it's easy to use. All you need to know is that it's a function divided by another function. So the key word here is divide. All right, let's do some examples. Here we have x divided by e to the x. Now this is relatively simple. We take the derivative of the numerator first always. So we want to take x prime, e to the x, minus, whenever you have division, you need to do, whenever you have quotient rule, you need to do minus. Then we take derivative of e to the x times x, divided by e to the x squared. Okay, now let's simplify. Derivative of x is just 1 times e to the x minus e to the x, because the derivative of e to the x is just e to the x, times x, divided by e to the x squared. And then what we can do here is we can simplify a little bit more. So we got e to the x minus x e to the x divided by e to the x squared. So then we can factor out e to the x. So you get 1 minus x divided by e to the x squared. And then we can cancel the squared and we can cancel the e to the x. So we're left with 1 minus x over e to the x. And that is our final answer. Let's move on to the next problem. The next problem is a bit of power rule and quotient rule, but I think it should be quite simple. So again, we always take the derivative of the top. So we want to take the derivative of x squared plus 2x prime times 10x plus 4 minus, always minus, derivative of 10x plus 4 times x squared plus 2x. Okay? And then we divide this by 10x plus 4 squared. Always remember that there's a squared at the bottom. It's quotient rule, so you're always going to end up with a fraction, right? Okay, let's take the derivatives now. So we get derivative of x squared. We've done this so many times. It's just 2x plus derivative of 2x. So we take 1 down. So it's 2x to the power of 0, which is just 2 times 1, which is 2, times 10x plus 4 minus derivative of 10x plus 4. 4 is a constant, so we don't need to worry about that. 10x, well, we take 1 down here. It becomes x to the power of 0. So that just leaves us with 10 times, and then we don't need to take the derivative of the second one, so it's x squared plus 2x. And then we divide that by 10x plus 4. Now, I don't see a way you can simplify this very easily, so I'm just going to leave it like this. But in some questions, you might have to simplify. So this, I'll say, is our final answer. Okay, last question. This one's probably the hardest question of them all, but it's still simple. The only thing is, right now, we have this function inside of another function. So that right there is chain rule, right? So Okay, let's set up, the first thing we need to do is we need to set up quotient rule, right? So let's set up quotient rule first. Okay, so we have x squared minus 1 cubed, and we take the derivative of that, times x squared plus 1 minus, always minus, x squared plus 1 prime times x squared minus 1 cubed. Okay, and then we divide that by x squared plus 1 whole squared. Always remember that. Okay, now we got to take this derivative, and this in and of itself is a different problem, right? This is chain rule. So let's identify what's our inner function with red. This is our inner function. And then with green, let's identify outer function, that's cubed, right? So what we need to do first is we need to take the derivative of the outer function. So we get 3 times, and then we leave the inner function inside. So that's x squared minus 1. And then we do, so this is just simple power rule. So it's just 3 minus 1. And then we want to multiply this by the derivative of the inner function. So we multiply this by the derivative of the inner function. So derivative of x squared, we already know that's 2x. And 1 is a constant, so we don't need to take the derivative of it. So it's just 2x. Now we just have to simplify this. So then we do 3 times 2x, which is 6x, times x squared minus 1 squared. Okay, that's the hard part of this question done. Now we just have the easy part left. Okay, we remember to put back the rest of the function. So we get times x squared plus 1 minus, and then we take the derivative of x squared plus 1. We just did that, it's 2x. So 2x, and then we leave x squared minus 1 whole cubed the same, and then we divide that all by x squared plus 1 whole squared. And I think maybe there's a couple ways you can simplify this. You can factor out x squared plus 1, x squared minus 1 here, and then you can factor out 2x as well. But I don't think that's the point of this video. We're just trying to practice quotient rule. So in terms of quotient rule, this is all that we have to do. And then you can simplify this based on what you need. But yeah, that's about it for this video. I hope this has made quotient rule and product rule a little bit simpler for you. And yeah, next video we'll be talking about implicit differentiation. So I'll see you then. Bye-bye.